When ChatGPT tackled this, it did what most of us do. It substituted n, expanded, and ended up with a massive quadratic expression. Only to factor the whole thing right back into a square. It gets the right answer, but why expand everything out just to pull it back together? Here's a much cleaner way using symmetry. Let x equal 2025 and y equal 2026, so a is just x squared plus y squared. Looking at 2a minus 1, we have two sets of x squared plus y squared. To form perfect square identities without expanding anything, here is the key move: we add and subtract 2xy. That let us group the terms directly into x plus y squared, plus x minus y squared, minus 1. Since x and y are consecutive numbers, x minus y is just negative 1. Square that, and you get positive 1, which completely cancels out the minus 1. Without a single line of messy expansion, the whole expression collapses to x plus y squared. Take the square root, add 2025 and 2026, and we get 4051. Now let's use geometry to solve the problem. Build a right triangle with legs 2025 and 2026. As a quick refresher, the Pythagorean theorem says that for any right triangle, squaring the two short sides and adding them gives the hypotenuse squared. So here, the hypotenuse is simply the square root of a. Now, build an identical twin triangle right beside it, but swap the leg positions. Where they meet at point C, they form a right angle, creating a larger isosceles right triangle with hypotenuse square root of 2a. Drop a horizontal line AF to lock in a rectangle at the bottom. Since the total height is 2026 and the rectangle height is 2025, that top segment EF is left as just 1. Now, look at line segment AF. Inside that top right triangle, using the Pythagorean theorem again gives AF as the square root of 2a minus 1. But as the top edge of our rectangle, AF is also just 2026 plus 2025, or 4051.